this that says you should find the tensions in the ropes T1 and T2. So you have a bag or a load, and this load is suspended using two ropes. One inclined at angle 40 to the wall, the other inclined at another side of the wall by angle 70. So how do you go about it? In this case, the two ropes don't have equal tension. That is why you can see T1, T2, because the force on this rope is not the same as the force on the second rope. So, but we can resolve this as well using the triangle method of vectors. And in that triangle method of vectors, we can look at the downward force. The downward force is a vertical line, which is 50. So this is the downward force here, 50 Newton. Then we are told that we have T1 inclined at angle 40 to the vertical. So let's say this place it is inclined at angle 40 here. That's your T1 here. You are told that T2 is inclined at angle 70. At angle 70 here. So this is T2. Then you have to find the third angle. The third angle is going to be sum of angle in the triangle is 180. Say 180 minus 70 plus 40. This will give you 180 minus 110. So the angle is equal to 70 degrees. So the angle here is 70 degrees. Then if you look at this triangle is an acute angle triangle because it is an acute angle triangle because none of the interior angle here is equal to 90 or greater than 90. So we can solve it using the sine rule. And you already know that the sine rule is A over sine A is equals to B over sine capital B. So let us apply that here. Pick if this is A, B, and C, and now pick A. Side facing A is T1, so T1 over sine A, which is 70, is equals to B. Side facing B is 50 Newton over sine. Side facing B is 70. So I'm to make T1 the subject here. Is going to be this times this, give you T1 sine 70 is equals to 50 sine 70. Divide both sides by sine 70. This cancel this cancel this. Your T1 is equals to 50 Newton. So the tension on the first rope here is equals to 50 Newton. So let's now resolve that of the tension on the second rope. So for us to find the tension on the second rope, we'll still make use of this formula here. Do you understand? This time around, our attention is on finding T2. So what we're going to do is we look at this. This is going to give us C, the side facing C, because this formula is the same thing as small c over sine capital C. So if I'm picking this against this now, I'm saying C, side facing C is T2 over angle of it is sine 40 is equals to B, which is 50 over sine 70. So if I'm to make T2 the subject, we're going to have that T2 sine 70 is equals to 50 sine 40. So divide divide both sides by sine 70. Sine 70 cancel sine 70, and now left with T2. Then press your calculator. 50 sine 40 divided by sine 70. 4.20 Newton. So the force on the second rope here, T2, is 34.20 Newton. Please don't forget to like this video, share this video with your friends, and if you have any question, drop your question at the comment section. Bye. A question like this, you're asked to find the tension in each rope, T1 and T2. So find the tension here and here. Then if you look at this, these are what? Three vectors that are in equilibrium. So these three vectors can also be resolved using triangle method. This method is very important in solving questions and vectors. So what are you going to do? We will now first of all represent the vertical vector. The vertical vector here, solution. The vertical vector we're given is 100 Newton. Then we are told that there is a tension T2 which is inclined at angle 90. This is angle 90 here. Inclined at angle 90. Then we are told that this is my T2 here. There is tension T1 inclined at angle 40 to the vertical. You can see it here. This one is inclined at angle 40. This is inclined at angle 90. So this is T1. We are to find T1 and T2. So if you are to do that, we need to find this angle here. What will be the angle here? The angle there will be equal to 180 minus 90 plus 40, which is equal to 180 minus 130, which is 40. Sorry, it is 50. So the angle here is 50 degrees. So if this is 50 degrees, then you look at this triangle. What type of triangle is this? This is a right angle triangle. This is a right angle triangle. And when you have a right angle triangle, the best way to solve it is to use the trig ratio or the Pythagoras theory. So we can resolve this one. We don't necessarily need to use sine rule to resolve this. So we can use trig ratio. Use the trig ratio to do this.